Okay, so we've spent the last week basically going over some algebra skills, preparing us for and allowing us to work through adding, subtracting, and the day before multiplying and dividing and simplifying rational expressions. So all that we're going to do today is to extend work and to do some extra, I guess, more difficult problems having to do with solving rational expressions. Okay, so I've been doing steps all the way along. Steps to simplifying, steps to multiplying and dividing, and then steps to success for adding and subtracting. So here I want to continue that idea in an overall or general sense. Okay, so here's an example of a question there. You'll notice that it's got quite a few things in there. There's division. Okay, it's got a rational expression here, here, and here. And it's also got addition. Now, following bedmass, of course, which we do need to do, then of course we're going to order the operations so that we take care of the division before we take care of the addition subtraction. But in general, you can approach any rational expression, no matter how many fractions, no matter what operators may exist in there, you can approach it as follows. The first step, that if you're asked to simplify and state restrictions, which you usually are, is to factor fully. And you've noticed that for every single one that we've been doing, whether it's simplifying, whether it's multiplying and dividing, whether it's adding and subtracting, we have been factoring first. And what that allows us to do is two things, but it really allows us to do step two, which is determine the restrictions. So first step is factor, okay? Second step is state the restrictions. When you factor, then you can state the restrictions much more easily because you can see what the restrictions are, especially in the denominator. But also when you factor, it gets you along the process. It lets you see that if there's an addition and subtraction, it lets you see the idea that there is commonality, and for looking for a lowest common denominator, it's nice to see all the bits and pieces that make up each of the denominators, whether it's a binomial or a monomial component, and how we put those together to build a lowest common denominator. It also, of course, helps in the canceling steps if we actually do get to that. Okay, whether it's a multiplication and division or addition, subtraction, whatever it may be. Okay, so in this case, step one is factor. Step two is restrictions. It's the same for every single operation we've been doing, even simplifying rational expressions. And then step three, because it's going to vary depending on whether it's multiplying and dividing or adding and subtracting, it's perform the operation. Okay, what operation is it that we need to perform? And in this case, we're going to perform division and then addition. Okay, and that is most of the work. I'm not going to lie to you, but it still is part of that process of multiplication, addition, division, and subtraction. Okay, so we use this example to work our way through it. So first step is to factor. We look to see what's in common here, 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 here. Nothing in common here. All we can really do is factor the denominator there. Okay. Second step, state restrictions. So here we look at the restrictions. We're going to see that, of course, well, 2, there's no constant value, or there's no variable portion in that denominator. There's a variable portion in this denominator. That's x is equal to 5, right? Or cannot equal 5, I should say. And then for this value here, x cannot equal 0. And then for this value here, x cannot equal -3. And so that's where we get these restrictions. However, remember, this is division. So for division, we have to worry about the numerator of the dividing fraction, or the fraction to the right of the division sign. So we also have a restriction where x cannot equal 4. Okay? So there are all our restrictions that are involved in there, including x cannot equal 4. Okay? Third step, of course, is we perform the operation. So the first operation, according to bedmass, we can't simplify any brackets. There's no exponents. So what we do is division or multiplication as we see it from left to right. In this case, we've got division. So what do we do with this particular fraction? It's already factored, right? So we flip it or multiply by the reciprocal. So the denominator becomes a numerator, numerator becomes a denominator, as you see here. And then we change the sign to multiplication. Again, we're performing that operation. So we take this x and we multiply it by this x times x plus 3. So x times x is x squared, and then x plus 3. And then the denominator, x minus 5 times x minus 4. We're not going to expand it out because we still want to have it in factored form. Okay, but we, to do canceling or even to do other operations later on. But we definitely need to work through that and make sure that we have all the things that we need. Now, there's no canceling that's going to be happening here at all in this multiplication event. All right, there's nothing in common between there's no monomial to cancel out within this fraction here. And there's no x plus 3 down in the denominator here. And there's no x minus 5 and x minus 4 in the numerator. So there's no canceling out there. Okay, so we do division first, and after that now, we do the second operation. In this case, it's addition. So we build our lowest common denominator, and remember how we build our lowest common denominator. We start with a monomial portion. There's a monomial of 2 in there, so we write down the 2. No other monomial components to it. So then what we do is we write down our binomials, x minus 5, x minus 4, write them down. Okay, and we've built our lowest common denominator. Next step after that to add is we have to make the denominators the same. So now make the denominators the same. And again, we multiply the fraction, numerator, denominator, by what is missing from the lowest common denominator. So if you look at the 2, there's a lot missing from this lowest common denominator. We have the 2, but what we need is we need x minus 5 and x minus 4. So that's what we do. We take that 2 and we multiply it by x minus 5 and x minus 4. What we do to the denominator, we have to do to the numerator. And so this fraction, to make it common, or to make it have a common denominator, we really have to modify it a great deal. For this fraction, you're going to notice that we have very little new that we need to do to it. In other words, if you look at our LCD, we've got a 2, an x minus 5, and an x minus 4. There's already in this fraction an x minus 5 and an x minus 4. So all we have to do is multiply it by 2. And so you see that here. You take this fraction, you multiply the denominator by 2 and the numerator by 2, because what we do to the denominator, we do to the numerator. Okay, and then what we do, of course, is we write all of it underneath one fraction. In this case, the fraction with the lowest common denominator of 2 times x minus 5 times x minus 4. And we're left in this situation here where we have 3 times x minus 5 times x minus 4 plus 2x squared times x plus 3 times x plus 3. The 2x squareds comes from this 2 multiplying by this monomial x squared there. So I've combined the monomials there before I've done any other expansion. Okay. Now, next step that we're going to do with this is we want to expand and collect like terms to see if we can maybe create a trinomial, tetranomial, whatever it is, where we have a binomial common factor or a monomial common factor that can cancel out. Okay. So we take this x minus 5 times x minus 4, when we FOIL method it out, we expand it out and get x squared minus 9x minus 20. Okay, and then we distribute the 3 into here, into here, into here, and we get 3x squared minus 27x minus 60. And then over here, we distribute the 2x squared into the x and the 2x squared into the 3 to get 2x cubed plus 6x squared. We then collect like, we carry this down here because there's nothing new to do, and we collect like terms. So we have 2x cubed. First, we should always go in order of decreasing degree. We've got a 3x squared and a 6x squared gives me 9x squared. I've got a negative 27x to give me a negative 27x, and I've got a negative 60 to give me a negative 60. And for our capabilities up past this point, we can't factor this any further. So we're left with a rational expression that looks like this. So all that we're left to do is restate and restrict. So if you look at it, of course, when I restate and restrict, I say, again, the original fraction is equal to my final result, right? And then I state my restrictions. X cannot equal 0, 5, negative 3, and 4. And it's done. So nothing crazy to do there, nothing mind-blowing to do. Here we've got a little bit more. This one's a little bit tougher to do because we've got 3 operations to do in here, but we're going to give it a go and see what we can manage. Okay, so first step, as always, is to factor. So here I go multiplies negative 4, that's a negative 3, and that factors to x minus 4, x plus 1. Okay, here we can common factor out a 2x, and then we have x minus 5. Nothing to cancel yet, but we'll keep on going. Here we factor out a common 4x squared, and we're left with an x minus 4. I don't know if there's an x minus 4 there, but, x minus 3. Excuse me. Okay, and then of course we have x squared minus 9, that's a difference of squares, so we go x minus 3, x plus 3, taking the square root of x squared and the square root of 9, and then plus and minus. Okay, in the division fraction or the divisor here, we've got a common 6x squared, and then we get x plus 1. And then here we have a common, no common factor. What multiplies to negative 15 adds to negative 2. That's an x minus 5. And that's an x plus 3. Okay, and of course this last fraction here, we cannot do any collecting like terms at all. Okay, don't mind them, that's just my dogs in the background playing. Okay, they may sound like they're a little angry with each other, but they're goofing around. Okay. Okay, so, excuse me, we keep on going. All right, we're going to state restrictions. Okay, and there's quite a few places where we have restrictions. So I'll state them over here because we've got a lot going on. So one restriction is x cannot equal 0. Another restriction is x cannot equal 5. Another restriction is x cannot equal 3. Another restriction is x cannot equal -3. Another restriction, oh, we've already got x cannot equal 5. We've already got x cannot equal -3. However, remember, this is a division, so I have to worry about this numerator. Okay, x cannot equal 0, but we already have that, and x cannot equal -1 for this particular factor right there. Okay, so quite a few restrictions that exist in there. Now, I'm going to try and do this multiplication and division event all at once, because what I can do is I can take this division, turn it into multiplication, and then flip that divisor fraction. So I'll just rewrite this. It's going to be a little bit onerous of a task. I'll show you the dogs afterwards if you want to, for those of you guys who are dog lovers. If you don't like them, then I don't know. At least you'll know what was making those noises, that it's not monsters. Okay. And then here I'm going to do the reciprocal for that fraction. And then I'm going to leave this x minus 2 that I'm subtracting afterwards. Remember, it's BEDMAS, so I'm going to do division and multiplication from left to right as I see it. But I've turned it into 3 multiplication events. So again, when we multiply, we've already stated restrictions. We multiply all the numerators. So x minus 4, x plus 1, 4x squared, x minus 3, x minus 5, x plus 3, all over 2x, oops, x minus 5, x minus 3, x plus 3, 6x squared, and then x plus 1. And again, we've got this lonely 1 over x minus 2 that I'm subtracting there. We'll take care of that later on. Okay, so hopefully we're going to have some canceling here, because it's a pretty big, again, we do have a fair bit of canceling here. So we've got the x, again, we've stated restrictions, we factored, so we can cancel. X plus 3, x plus 3, x plus 1, x plus 1, x minus 5, x minus 5. And I think in the numerator, we're left with definitely an x minus 4 as a binomial that's there. Okay. And we can still cancel monomials, but at least that's my binomial there. So now my 4 and my 2 can cancel out to leave me with 2 in the numerator. The x and the, you know what, I'm not going to cancel that x, because over to the right here, I have an x squared that will cancel beautifully with that x squared. And the 6 will cancel with that 2 that's left over. So now in my numerator, you're going to see I just have x minus 4. Everything else is canceled out. In my denominator, I'm going to have an x, and then I'm going to have a 3. So that's it. Well, that's pretty boring. Well, it's not boring. There certainly was a lot going on there. Very satisfying. Lots of canceling going on there, right? X minus 5, minus 5, 3, 3, negative 3, negative 3, 1, 1. Yeah, so that's it as it is. Minus 1 over x minus 2. Okay? So now, of course, we have to can do another operation. We're completing the operation, so we're going to look for a lowest common denominator. In this case, it's going to be a pretty easy one. It's just going to be 3x, my monomial component, and my x minus 2, my binomial component. So I take this particular fraction here. Remember, I'm making the denominators the same. So I need an x, if you look at your lowest common denominator, I want to add an x minus 2 in there. Or not add, but multiply by x minus 2 to create the same as the lowest common denominator. And of course, what I do to the numerator, I have to do to the denominator. Then I have this one, 1 over x minus 2. And what do I have to multiply that by? Well, again, x minus 2 is there, but I need a 3x, so I multiply by 3x in the numerator and the denominator. And I'm left with the numerators, and then, of course, over the common denominator. The common denominator is going to be 3x times x minus 2. The numerator is going to be x minus 4, x minus 2, minus 1 times 3x, which is 3x. I'm going to go on over here. Oops, there we go. Okay, and I'm going to expand out this binomial and see if when this collects with it, it becomes factorable. Who knows? Maybe it will, maybe it won't. So x times x is x squared. Negative 4 times x is negative 4x. Negative 2 times x is negative 2x, so it's overall a negative 6x. And then negative 4 times negative 2 is a positive 8. And then f minus 3x all over my denominator, 3x, x minus 2. Finally, when I have a closer look at this, I realize, okay, if I take away this middle term, oh, is it possible that this is factorable? Exciting. If you look at what multiplies to give you 8 and adds to give you negative 9, it's x minus 8, x minus 1, all over 3x, x minus 2. Okay? But, unfortunately, that's to no avail because, of course, we can't find anything to cancel out there. So whether you want to leave it in this format or in this format, it doesn't make a difference. However, here you can see zeros, so if you're going to analyze the function and look at its behavior, this would be a little bit more useful for you to do if it's possible, to factor. So, last step, of course, which is simplified as it's going to get, we restate and restrict. So we say, I'm going to be a little bit lazy, I'm going to say, therefore, this mess is equal to x minus 8, x minus 1, all over 3x, x minus 2, and then I state my restrictions. X cannot equal 0, negative 1, negative 3, 5, 3. Okay, and those are all the values that are not allowed. So that's an example of an application question, and that gets us to really, flex our muscles when it comes to our ability to simplify rational expressions. And this example is a little bit different. It's just sort of an application question that relates to somewhere in this unit. Okay, so here's a figure. There's a shaded region. This is x plus 3. This is x plus 1. This part here is x plus 5. This part here is x plus 4. And it says, write and simplify an expression for the area of the shaded region. So first of all, I'm going to plan this out. My area of my shaded region is going to equal, well, if I figure out the area of this big rectangle, and I subtract the area of this little triangle, then I'll be able to have an expression that represents the area of the shaded region. You could also maybe break it into a composite figure and do this area here and then do this area here and then add them up. But in this case, this is what I've decided to do. So you can take a different strategy if you want to. So what is the area of this one? Well, the area of the small is not too bad. The area of the small is just x plus 3 and x plus 1. It's this unshaded white square here. We want to remove that from the larger rectangle. The area of the larger rectangle is going to be this side right here. So what is this side? It's x plus 5 and then x plus 3 or 2x plus 8. Okay, for this full region here. And for this, maybe I'll go over here. This full region here, it's going to be the x plus 4 plus the x plus 1 or 2x plus 5. X plus x, x plus x, 4 plus 1, 2x plus 5. Or x plus x, 2x, 3 plus 5, 8. And so the area of my big rectangle is going to be 2x plus 8 and 2x plus 5. Okay? So we figure out the area of the big rectangle. And so we expand this out. Okay, so just say write and simplify an expression. So we should expand it, collect like terms. Doesn't necessarily mean that we have to factor it. It's not a rational expression, but it's just an expression that we're doing. So this is more of a question from 2.1 or 2.2 or something like that. So 2 times 2 is 4x squared. 8 times 2 is 16x. And then 2x times 5 is going to give you 10x. And then 8 times 5 is going to give you 40. And then minus, I'm just going to do this in brackets, x times x squared plus 4x plus 3. Then you go 4x squared plus 16x. Oops, so I can add those up. 16x and 10x plus 26x plus 40. And then distribute this through x squared minus x squared plus, oops, excuse me, minus 4x, negative times 4x, and then a negative times 3 is minus 3. And so I'm left with 4x squared. 26 minus 4 is plus 22x, and then plus 37. Okay? So that is an expression for the area of the shaded region. Okay, and that's all they wanted to do, us to do in A. In B, kind of relates to this, so we should have it somewhere close by. Okay, write and simplify an expression for the ratio of the perimeter to the area of the shaded region. So we have the area of the shaded region, which is 4x squared plus 22x plus 37. Okay, and that's 120, 148, 148. I don't know what multiplies to give me 148 and adds to give me 22. It's not 12. I don't know, we'll have to figure that out. Anyway, and what we want to do is ratio the perimeter to the area of the shaded region. So the perimeter of the shaded region, you just have to walk your way around this rectangle. Okay, I'm going to write it in a columnar fashion. So I don't know, I'll start here. I'll go x plus 4, x plus 3. X plus 4, and then x plus 3, and then x plus 1, and then x plus 5, and then this side here, which is 2x plus 5, and then this side here, which is the long side, which is 2x plus 8. Okay, and 4 and 3, it's 8, another 8 is 16. And then, so that's 26. Carry this, 26, carry the 2, so 26. Plus, and then we go x plus x plus x plus x, that's 4x, 6x, 8x. So 8x plus 26. Okay? So now we want to know a ratio for the perimeter to the area of the shaded region. So my ratio here, perimeter to area is equal to 8x plus 26 is to 4x squared plus 22x. 26 plus 22x plus 37. Okay? Or 8x squared, or 8x plus 26, and rather than using the ratio, we could write it as a fraction. 4x squared plus 22x plus 37. Okay? And then from there, we, of course, would want to write in simplify. So we would want to look to see if we could factor numerator and denominator. I don't have a calculator handy, and I can't use my phone because I'm using it to tape. I'm going to have to press pause and do a part 2 because I don't have a calculator handy. I guess I could do it by hand, but it's been a while and it's later in the night, so give me a moment and I'll be back.